Okay, so here you have the equation of parabola, and some point P is given on the parabola, and basically Q is a point where the parabola cuts the y-axis. So you have to basically find the distance PQ. Now, before you solve this question, I would like you to go through some concept of parabola, and those important concepts are, and this would also be covered under the translation of graph. So few important things that you should know before you solve this question is: one, the standard equation of parabola is y is equal to x square, and the graph looks like this. This is how a parabola would look like. So this is the origin, and this point is called the vertex of the parabola. Vertex of the parabola, right? Okay. Second, what if we try to find out the graph of y is equal to x square plus 1? How would this look like? Now, as we can see, in the value of y is equal to x square, what we've done is we've added 1 unit, right? So we've added 1 unit. So what would happen is the graph would jump 1 point above. So this is how it would look like. This distance is going to be 1. And if we have to figure out what would be the vertex of this parabola, so the vertex is going to be in the horizontal. We are not moving anywhere. So horizontal is 0. Vertical, we've moved 1 point up. So vertex is 0, 1. So to remember, any point on the y-axis, if you take on the y-axis, any point would have the x coordinate 0. And similarly, on the x-axis, if you take any point, it would have the y coordinate 0, because we are not moving in the vertical. Okay. Now, third equation, y is equal to x square minus 1. Similarly, this equation, we have minus 1. So the equation would look very similar, but then the graph would look very similar, but then it would dip 1 point below the origin. So if we have to find out the vertex of this parabola, it would be in the horizontal, we are not moving anywhere. In the vertical, we've gone down 1 point, so it would be 0 minus 1. Now, how would the equation of graph y is equal to x plus 1 whole square would look like? Now here we need to be careful. Here something opposite happens, because we're adding the value to x. So the rotation would be along the x-axis, not along the y-axis. And we've added 1 point. Here the reverse thing happens. The graph would shift 1 point left of the origin. 1 point toward the left of the origin. So this is how the graph is going to look like. And the vertex would be here. In the horizontal, we've moved 1 point toward the left, so minus 1. And vertical, we've not moved, so minus 1, 0. Similarly, y is equal to x minus 1 whole square. How would this look like? So just the opposite happens. So minus 1. So while the graph would shift 1 point toward the right of the origin. So this is how it is going to look like. And the vertex would be on the x-axis, we've moved 1 point, so it is 1. And y-axis, we've not moved, so the coordinate would be 1, 0. So this is the background information you required, and now you can comfortably solve this question. Okay, give it a try, students. Okay, you can pause and try this question. Okay, hope you've tried this question. So let's try and solve this. So the equation of the parabola is y is equal to x square minus 3. So based on this discussion, we can draw the graph of this equation. So it would dip 3 points below the origin. So this is how it is going to look like. 3 points below the origin. So the coordinate of this point, the vertex, would be 0, minus 3. Okay, what else do we know? And this point is, by the way, Q as per the question. Okay, because it cuts the y-axis at point Q, right? So this is the y-axis, this is the x-axis. Okay, now point P is on the parabola. Let's say point P is over here and the coordinates are 2, k. And what do we have to do? Distance between P and Q. Now, we can use the distance formula, but the only challenge is we do not know the value of k. So let's try and find out the value of k. Now, since point P is on this graph, y is equal to x square minus 1, so these points, these coordinate, that is the value of x as 2 and the value of y as k, would satisfy the original equation. So whenever a point lies on a particular graph, on a particular equation, then that point would satisfy the equation of whatever equation has been given. So let's substitute x is equal to 2 and y is equal to k in the original equation, and let's see what do we get. Okay, let's put y is equal to k is equal to, instead of x square, what do we have? X is equal to 2, so 2 square minus 3. So this is 4 minus 3, which is equal to 1. So now we have k is equal to 1. So here k is equal to 1. Now all we have to do is just apply the distance formula and find the distance between these two points using the distance formula. So distance is x1 minus under root of x1 minus x2 square. Let's say this is 0.1, this is 0.2. So x1 is 2 minus 0 square is 2 square plus y2 minus y1 minus y2 square, that is 1 minus 3 whole square. What do we have? 2 square is 4 plus 1 minus plus 1 plus 3, 4. 4 square is 16. So we have under root 20, which is 5 4s are 20, 2 common, 2 outside, and under root 5. 2 root 5 would be the correct answer. Hope you got this question. Let's move on to the next one. Alright, so give it a pause and try this question. You have to find out the y-intercept of this line. Okay, hope you've been able to solve this. And in case you've not been able to solve this, a hint for you is, since they are asking the y-intercept, and in this line you have 2 points that are already known to you. You can call them x1, y1 or x2, y2. Quickly you can find out the slope, right? If you know x1, y1, x2, y2, you can quickly find out the slope. So what should come to your mind? Slope intercept form. Y is equal to mx plus c, right? Y-intercept has to be found out. C, this can be found out. M you can calculate. Let's calculate m over here. M would be equal to y2 minus y1 upon x2 minus x1, which would be equal to 4 minus 6 upon 6 minus 3, which is minus 2 by 3. So slope m we already know. Now another thing, so the equation would be y is equal to minus 2 by 3 x plus c. Now another thing that we can use from the information given to us is that since these 2 points, they lie on this line, so these 2 points would satisfy this equation. So either of the 2 points, if we put the values of x1 and y1 in place of x and y, these points would satisfy the equation. So we can take any of these points. Let's take x1, y1. So instead of x, let's put x1, that is 3, and instead of y, let's put y1, which is 6. And the equation would still hold true. So y1 is y is equal to y1, which is equal to 6, is equal to minus 2 by 3, and x is 3 plus c. Now the only unknown variable in this equation is c, so we can find out the value of that. 3 gets cancelled, so c would be 6 plus 2, which is 8. So c is equal to 8. That's your answer. C is nothing but the y-intercept. B is the correct answer. Hope this is clear. Now let's move on to the next question. Okay, guys, so this is a question on quantitative comparison. Try and attempt this, and the answers, you have to pick one of the 4 answers and your answer would be A when you find that the quantity in column A is greater than quantity in column B. You'll mark answer choice as B if you find out that quantity in column B is greater than quantity in column A. You'll mark C if you find out that both the quantities in column A and column B, they are same, they're equal, and you'll mark D if, based on the information, this relationship cannot be determined whether A is greater or B is greater. So when it can't be determined, then your answer would be D. Okay, so pause this video and try to attempt this question. Okay, hope you've been able to solve this. So what has been given is the function fn has been given, and variable n is there, c is there, where c is a positive constant, this question says. And the difference, another information is the difference between the largest and the smallest among f1, f2, f3 is 20. And we have to find out the value of f4 and compare it with 16. Okay. Since the question talks about f1, f2, f3, let's find out what these values would be. f1 would be equal to, so in this equation, in this expression, or in this function, let's put n is equal to 1 and see what do we get. Minus 1 power 1 into c into 1. So minus 1 power 1 is nothing but minus 1 into c is minus c. f2 would be equal to, similarly, minus 1 power 2. So instead of n, we're just putting the value as 2 into c into n. N is equal to 2. Okay, so what do we have? Minus 1 square, that is minus 1 into 1 is minus 1 into minus 1 is 1 into 2 into c, so we have 2c. Similarly, f3 would be equal to minus 1 power 3 into c into 3. So minus 1 power 3 is minus 1, minus 1 into minus 1 into minus 1 into 3 into c, which is equal to minus 3c. And the question says the difference between the largest. Now, out of these three students, which one is the largest? Naturally, the positive number would be the largest. 2c would be the largest. And which one would be the smallest? Minus 3c would be the smallest. So the difference would be largest minus smallest. 2c minus smallest is minus 3c. That is equal to 20. So 2c plus 3c is equal to 20. So 5c is equal to 20. C is equal to 4. Alright, C is equal to 4. But what are we supposed to find out? We're supposed to find out F4. So F4 would be equal to, in the same way as we found out F1, F2, F3, F4 would be equal to minus 1 power 4 into C into 4. So minus 1 power 4 is 1 only, and C we've just calculated is 4 and into 4. So 4 into 4 is 16. So F4 comes out to be 16, and so value in column A is 16, value in column B is also 16. So answer would be both are equal. C is the right answer. Hope this is clear. Let's move on to the next question. Okay. Here what you're supposed to do is you are supposed to find the slope of point BC. So pause this video and solve this question. Okay, hope you've been able to do this. So guys, there would be two ways in which you can solve this question. And they're based on what we've learned about the slope of a line. So slope is defined as tan theta, and where theta is the angle with the positive x-axis. So we can utilize this and find out the slope. So here of line BC, the angle with the positive x-axis is theta, which is equal to how much this angle would be equal to. Now, as you can see in this triangle, all the sides are 5. They're equal. So this one is an equilateral triangle. So all the angles are going to be equal to 60 degree. This is 60, this is 60, this is 60. Now, AB is basically nothing but a straight line. This angle is 60. So theta would be 180 minus 60. That is 120 degree. Now, all you need to do is just find the value of tan 120 degree, and that would be your answer. So tan 120 degree would be equal to how much? Tan 120 degree would be equal to minus root 3. So E would be your correct answer. Now, those who did not understand how I have been able to figure out that tan 120 degree is minus root 3 can use this expression. Tan 120 we can write it as tan 90 plus 30, and tan 90 plus theta is minus cot theta. Now this is your theta minus cot 30, and cot 30 is how much? See, tan 30 is 1 by root 3. Cot 30 would be reciprocal of it, because cot 30 is nothing but 1 by tan 30. So 1 upon under root 3, that is root 3. So minus. So this is what I wrote. Now, if you want to understand how this sort of conversion works, is so for that you can basically make a note of this table. Let me tell you this conversion, and these are very important, not only for trigonometry, but also we've seen that it is instrumental in coordinate geometry. So sine 90 minus theta, cos 90 minus theta, tan 90 minus theta, sine 90 plus theta, cos 90 plus theta, tan 90 plus theta. Now let's try and find out the value. Sine 90 minus theta is cos theta, cos 90 minus theta is sine theta, tan 90 minus theta is cot theta. Easy. Sine 90 minus theta is cos theta, and cos is reverse. 90 minus theta is sine theta, tan 90 minus theta is cot theta. Write the same thing for sine 90 plus theta, cos 90 plus theta, tan 90 plus theta. That is sine 90 plus theta, cos theta, cos 90 plus theta, sine theta, and tan 90 plus theta, cot theta. Now, in case of the last three, we need to be particular. We need to be careful about the sign. See, why 90 minus theta, all of these are positive? Because cos theta, sine theta, cot theta, because 90 minus theta would all lie in the first quadrant, because this is 90 degree and minus theta. We are assuming that theta would be between 0 and 90. So this would be an angle in the first quadrant, and all sine, cos, tan, they are positive in the first quadrant. But in the second quadrant, we need to be little careful. 90 plus theta would be an angle in the second quadrant, because this is 90 and some angle theta is being added, which is between 0 to 90. So this would give you an angle in the second quadrant. Now in the second quadrant, sine theta is positive because perpendicular is positive, hypotenuse is positive. Hypotenuse is nothing but a distance, right? So perpendicular square plus base square. How can square of a number be negative? So sine theta is positive, perpendicular upon hypotenuse, but base theta is negative, but cos theta is negative. Why? Because cos theta is base upon hypotenuse. Now base is negative in the second quadrant. So this is going to be a negative value. Cos 90 plus theta is minus sine theta. Similarly, tan 90 plus theta is also minus cot theta, because tan theta in the second quadrant is basically negative. Okay, let's come back to our original question. All right. Now, first method you've seen. Second method could be the conventional method, in which you can find out the coordinates of point B and C and use the distance formula. Now, the coordinates of point B would be in the horizontal, we've moved 5 points, so this is 5, and in the vertical, we've not moved any distance, so 5, 0. Now, in order to find the coordinates of point C, we can utilize this property that in an equilateral triangle, if we draw a perpendicular from a vertex to the opposite side, it bisects the opposite side. And this is true for isosceles triangle also. So this distance would be equal to, bisect is cut into two equal parts, right? And this also distance would be 5 by 2. So x coordinate is nothing but the horizontal distance from the origin, which is equal to 5 by 2. So this is 5 by 2, and vertical distance would be how much? See, you know the hypotenuse. Now you know the base also, 5 by 2, you can calculate the perpendicular. So hypotenuse square minus base square would be perpendicular square. So we take the under root. So that would come out to be 5 root 3 by 2. And now just use the distance formula. call it x1, y1, x2, y2. You can do the other way around also as far as this nomenclature is concerned, and use the distance formula, that is x1 minus x2 whole square, y1 plus y1 minus y2 whole square, under root of that to find out the distance BC. Try to solve this on your own and verify that you're getting the same answer as minus root 3. Okay, hope this is clear, guys.